So in this video we will start salt solutions, and we are studying in chapter number 16. So in salt solution, so what is salt? First is, what is the definition of salt? Salts are ionic compounds formed from the reaction of an acid and a base. So here we have, usually salts are metal and non-metal. Salts are a compound of metals and non-metals, and we can abbreviate with them like Mx. X is a non-metal and M is a metal. Here we are going to take HX. H means acid. This is inorganic acid. And MOH is for metal, and hydroxide means base. So when acid and base react, they form salt and water. So this reaction is called an M for metal. This reaction is called neutralization reaction. Neutralization reaction. So in case of neutralization reaction, we react with the acid and base, they form salt. And let's see some more characteristics of the salt solution. What are the properties of salt solution? So salt in solution, Mx, whenever we dissociate into the water, whenever we dissolve in the water, they always make metal salt, metal ion and non-metal ions, anion and cation both. So each ion formed has the potential to react with water to produce the acid or base that it come from. So as we have seen in the previous video, that salts are made up of what? Acid and base reaction, and once the salt dissolve in the water, basically they make a water solution either acidic or basic. And this process, such reaction with the water, is called hydrolysis. Hydro means water. Hydro means water, and lysis means breaking, right? So water breaking. If an ion react with water through a hydrolysis reaction, a pH changes occur. Depending on the salt, a solution can become acidic, basic, or remain neutral. So how we can decide which salt will produce acidic solution, which salt will produce basic solution, and which salt will remain give a neutral solution when it will be dissolved in the water? So let's see an example, and before that example there are few simple rules that ions that react in the water by hydrolysis. What are the ions react with the water and they by the hydrolysis? So ions that came from a weak acid or weak base. For an example, acetate ion, ammonium ion, they react with the water, and so they are all ions are acetate ion. When react with the water, it form, basically it take one proton from the water and it forms CS3COOH acetic acid plus OH ion And because of this OH ion, since hydroxyl ion concentration increases in the water, so this ion will make water basic. So this ion will give the basic solution. And ammonium ion when it react with the water, it donate one proton to the water. So what happen here, it form H plus ion, or H plus ion remain with the hydronium ion with the water in the form of ammonium ion, in the form of hydronium ion, and plus ammonia. So here you can see this hydronium ion means hydrogen ion concentration increases, that is why pH will decrease and the resulting solution will be acidic. So this is the way salt changes the pH. These ions have an effect on the pH of the solution. Ions do not react with the water. So this is the important part here. You have to emphasize that what type of ions do not react with the water. So ions that come from strong base and acid. So weak acid and weak base ion can react with the water, but the ions which are coming from strong acid and strong base, they do not react with the water. For an example, chloride, bromide, iodide, nitrate ion, chlorate ion, perchlorate ion, sulfate, bisulfate ion. So 1, 2, 3, 4, 5, 6, 7. So these are the 7 ions which are coming from 7 strong acid. If you remember that there are 7 strong acid. Seven strong acids, and if you ionize them, these are the anions will come, and these anions do not react with the water. Another thing, sodium, lithium, calcium and barium, they are also do not react with the water. So plus water, no reaction. Right, so these ions remain in the water as in the form of ions, they do not react with the water. These are known as neutral ions. So these are known as neutral ions, and the salt made from these are called neutral salt. So this is very important. We must remember that because this line is very important to understand the another slides, what ions react with the water and what ions do not react with the water. So let's take one example. For sodium acetate ion. So sodium is a metal, this is metal, group 1 metal, and this part is acetate ion, which is non-metal. This is all combination of non-metal. And once it will dissociate in the water, it forms sodium ion and acetate ion. And as per the previous slide, we know that sodium do not react with the water. So sodium ion do not react with the water. Sodium react with the water, but sodium ion do not react with the water, because even if it will react with the water, it will form sodium hydroxide, and sodium hydroxide is a strong base. It will again go back to the ions. So there will be no reaction with the water for sodium ion. What about the acetate ion? Acetate ion is usually coming from weak acid, which is acetic acid. That is why it will react with the water and it will form an equilibrium. So once it will form equilibrium, weak acid, and it will increase the concentration of hydroxyl ion in the water. That is why the solution will become basic solution. And in case of sodium ion, sodium hydroxide is a strong electrolyte, dissociate completely into sodium ion and hydroxide ion. That is why there is no reaction with the water. So let's continue to the some more examples, that what will happen when the sodium acetate is dissolved in the water. Predict whether the salt solution containing the following salts are acidic, basic or neutral. How we can predict? So what we can do, we have to memorize this one, that we have already seen sodium acetate, that once it will dissolve in the water, it will dissociate into sodium ion and acetate ion. Sodium ion do not react with the water, only acetate ion will react with the water, and they will increase the hydroxyl ion concentration. That is why the solution will be basic. Then what about the ammonium bromide? In case of ammonium bromide, if you will dissociate ammonium bromide is not a strong salt, there is no metal right now here, so basically it is a exist in the equilibrium. So it will form, it will dissociate into ammonium ion plus bromide ion, and ammonium ion, when it react with the water, it form ammonia NH3 because it donate one proton to the water, and ammonia is a weak base, right, plus hydronium ion H3O plus. So hydronium ion concentration is increasing in the water, or hydrogen ion is concentration is increasing in the water, so solution will become acidic. But what about the, and pH will go below 7, pH will go below 7, right. What about the bromide ion? Since bromide ion, we have seen in the previous slide that it is coming from the strong acid, that is why it won't react with the water, so no reaction. Even if it will form, what it will form? It will form HBr. HBr is a strong acid. And all the strong acids dissociate 100% into hydrogen ion plus bromide ion. That is why bromide ion will remain as such in the bromide ion in the water, and it won't react with the, that is why it won't react. So do not affect on pH. So there will be no change in the pH due to the bromide ion. So let's see what happened with the sodium chloride. So I have already written here, so I will use this written part. Let's submit this paper first. Sodium chloride once will dissociate sodium ion and chloride ion. As we have seen that sodium ion also do not react with the water because it is coming from a strong base. If we will react with the water, it will form sodium hydroxide, and sodium hydroxide do not react with the water, so no effect due to the sodium ion. What about the chloride ion? Chloride ion is also coming from a strong acid. Sodium ion is coming from a strong base, and chloride ion is coming from a strong acid HCl. So it will also dissociate 100% into ions. That is why neither sodium ion will change the pH nor chloride ion. The solution will be neutral, and the salt is called neutral salt. Ammonium chloride salt will be called as an acidic salt, and sodium chloride salt will be called as a neutral salt. What about the ammonium cyanide? Let's dissociate ammonium cyanide into ammonium ion and cyanide ion. Ammonium ion react with the water, it will form weak base ammonia, ammonia is a weak base, and hydrogen ion it will increase, so hydronium ion will increase in the water. And what about the cyanide ion? Cyanide ion will also react with the water to form the HCN, and this is also weak acid, and hydrogen and hydroxyl ion. So we need to calculate to determine it acidity or basicity. So if both are coming from the weak acid or weak base, we have to really understand which which concentration is higher, whether hydronium ion concentration is higher or hydroxyl ion concentration higher. Then we have to calculate. So this type of salt we have to calculate, and we'll see one example in the next week and the next video. And if we summarize this one, so let me show you here. Here is this very interesting slide that shows if a strong acid and a strong base are reacting, they will form neutral salt. If weak acid and a salt is formed by weak acid and strong base, it will give us basic salt. If a weak base and strong acid salt is made of from these, a strong acid and weak base, it will form acidic salt. If any weak acid and weak base are involved in the making salt, then we have to must calculate. So we'll see one example in the next video to understand this.